in voltage. It's a floating electrical system, so they are not ground to the same system. Therefore, it has another potential than the future metro will have.
What are the legal implications of your system creating problems in other people's structures?
That's a very good question. I know that the existing metro, they already had somebody come and say, you're causing problems to us.
Right.
Documentation, first of all, and then the legal system will take over from there, I'm sure. We have these trains, these are places where we have trains crossing the line at different places. It would also be crossing the existing metro. And maybe some of you heard that we have an amusement park which is called Tivoli in the center of Copenhagen. All the amusements are direct current operated. We did not do anything about that. We did not even send in a junior engineer to test them out and while we were measuring, but maybe we'll do that in the future. We made a model in order to evaluate the consequences of these stray currents. We did a 3D model based on Abacus that also has an electrical model in it. We lined up the entire system in relation to resistance on the tunnel segments and the ballast concrete and the structural concrete. We know the composition and we know what the resistance will be under different circumstances. And we calculated then the current density. As it's a 3D model, we can calculate the current density as vectors. And it's the current density is not as much. And I should include that in the model we also modeled all the reinforcement bars. Not all of them. We had to model them as square reinforcement because making them round killed the modeling work, of course. If we do not include the reinforcement, the result that we get would be erroneous because current would concentrate where you have the very low resistances. That means your current density will locally be much, much higher compared to if you just look at an average on a steel structure. So the interesting current densities are those that are perpendicular to our steel structure because that's where the current is discharging and where we can have a risk of corrosion. I should include that all the input parameters, a lot of the material characterized, we estimated those. But we have a lot of measurements from the existing metro, which is also a new metro. We can use on what the voltage differences between the rail and the grounding mat underneath the rail was in a number of cases. We did a number of different modelings, both with and without an overlying rail. Yeah?
Oh, very quick question here. I just stepped in.
Yes.
Sorry if I
Welcome.
show like stupid. For stray current, my understanding is that if you will grounded, it should be okay.
If you ground it, it's okay. If all has the same potential, you're okay.
Okay.
It's when you have potential differences, you have the challenge.
So same potential, but the grounding is going to be grounded outside of the tube or within the tube. The
design normally allows you to ground inside within the tunnel structure itself. But this one is not connected to an overlying S-rail, for instance.
Mm-hmm.
And it's also not necessarily the same voltage as the tunnels.
Mm-hmm.
For safety reasons, if the voltage exceeds 120, or in some places they only use 90 volts. If the voltage exceeds that, for safety reasons, for step voltages and touch voltages, they make a short circuit. Then you would have a direct current leak. But in the operation condition, you can have voltages between them also. And then they design having a mesh, a stray current mesh underneath the tunnel rails to take out some of these stray currents over there. We included that mesh also in our model. But even doing so, what we found that the current density could not be said to be insignificant in an operation condition like this. On this one, you can see a cross section. This is where you have the tunnel segments meeting one another, and of course you have a lower resistance in this area and therefore susceptibility of currents entering and discharging. And you asked about the LIGO case. We have used all this information to design a corrosion monitoring system for the new metro line, including in this design not only having the normal corrosion monitoring you've seen, we've designed also monitoring system for the stray currents. With the new design, we are able to look at both potentials, gradients, and orientation. This means that we now have a strong tool whereby the metro system, if somebody comes and says you're causing trouble, they can go and evaluate whether they are the interferer or whether they are being interfered with. Concludingly, generally corrosion monitoring, we take that as an integrated part of service line. How else are you to confirm the service line design you do? How are you to plan for maintenance? You cannot do a preventive maintenance if you cannot predict when you have an onset of corrosion. And also it's a strong tool to look for hidden degradation at areas where you're not able to make inspection.